Let's take a look at this problem. Given 100,000 units are produced, the Cobb-Douglas production function is given by this equation. So we got 100 x to the 0.55 power, y to the 0.45 power is equal to 100,000. It says find a rate of change of y with respect to x when x is equal to 1,000 and y is equal to 800. So we want to find dy dx, or find y prime equivalently. Well, first thing I notice is I can go ahead and divide both sides by 100 and simplify it a little bit. So let's go ahead and do that. So divide this side by 100 and divide this side by 100. And we got x to the 0.55 power and y to the 0.45 power. It's equal to 1,000. Excuse me. Now we want to take the derivative of everything where it's sitting. So we'll take the derivative with respect to x of x to the 0.55, y to the 0.45, and we'll take the derivative with respect to x of 1,000. Well, this is a product rule. This will be p, and this will be q. P prime. If you have x to a power, you take your power, put it out in front, lower your power by 1. So we got 0.55 minus 1. Now for q prime, we'll do the same thing. Take your power, put it out in front, lower your power by 1. But we have to add on a y prime here, because remember, if you're taking the derivative with respect to x and it's a y, we always have to add on that y prime. Well, we got p prime q plus p q prime. So we're ready to plug in. P prime is 0.55x, and I'm not very good with decimals. Let me actually plug that in. I think it's negative 0.45, but I absolutely hate decimals. Okay. So I got excuse me. Minus, I'm going to go rest after I get this video done. Negative, or this section I should say, negative 0.45 like I thought. Okay, and that's p prime. Now q, that's y to the 0.45. Plus p, which was x to the 0.55, times q prime, which is this, which would be 0.45, y to the negative 0.55, I believe, y prime, equals, derivative of 1,000 is 0. Well, first off, I'm going to get rid of the negative exponents. So we're going to have 0.55, y to the 0.45, and then I'll take the x to the 0.45 to the denominator, because the negative exponent then becomes a positive. Plus, and here I'm going to have 0.45 x to the 0.55, and I'll take that y to the negative exponent down below, and it changes the sign of the exponent to positive. Y prime is equal to 0. Well, there's really no need for me to simplify this. I'm going to go ahead and plug in my values, because they tell us in the problem that x is 1,000, and they tell us y is equal to 800. So I'm going to plug those values in. So I'm going to have 0.55, then y, which is 800, to the 0.45 power, over x, which is 1,000, to the 0.45 power, plus 0.45, x, which is 1,000, to the 0.55 power, and then y, which is 800, to the 0.55 power. Now I'll change the y prime to m equals 0. Because we're wanting to find a rate of change, which will be our m. Well, let's plug these in our calculator. Looks like no need to work that hard. So I'll put 0.55 times 800 caret 0.45 divided by 1,000 caret 0.45. And enter. Gives us 0.49, 745, 429, 36. Plus, and then let's plug this one in. Now notice I didn't round it at all, did I? So don't round it. 0.45 times 1,000 caret 0.55 divided by 800 caret 0.55. And that gives us, excuse me, 0.508 760073 m equals 0. Okay. Well, I want to solve for m, so I'm going to take this number, move it over to the right side. So then we're going to get 0.508760073 m is equal to negative 0.49 42936, and then divide both sides by the number in front of our m, and we got m is equal to negative 0.49 42936 divided by 0.508 760073. Okay. Negative 0.497454 2936 divided by this previous number. So I'm just going to do a second negative to bring up the previous answer, because I already had that. You would probably need to type it in your calculator and then press enter. And I'll round this to I don't know, 5 decimal places maybe. I don't know, 0.97778, and that'd be our rate of change. Almost negative 1.